This lesson is on the stopping distance of vehicles. So our title today is Stopping Distance. Our objectives are that we should be able to state what is meant by stopping distance, thinking distance, and braking distance. We should be able to describe the link between stopping distance, thinking distance, and braking distance, calculate the thinking distance at various speeds, and finally describe factors which can affect braking distance. So we should set up our notes in the Cornell note-taking system with our objectives on the left posing as questions, and on the right in our notes we should match up our answers to those questions. So as a driver, you may be posed with a mannequin of a small child jumping out at you on a trolley. In this case, your car needs to be able to stop within a distance to prevent you from colliding with that mannequin. So we have the idea of stopping distance. Stopping distance is composed of two parts. First of all, thinking distance. That is the time between seeing the mannequin of a child on a trolley and reacting to it by putting your foot on the brake. Then the second factor is the braking distance. That is, once you put your foot on the brake, how far you travel before your car can actually come to a stop. So as we can see, we have various different thinking distances and braking distances depending on the speed. So for 20 miles per hour, which is approximately 10 meters per second, you'll find that your thinking distance is 6 meters and the stopping distance is also around 6 meters. That is assuming good weather conditions. So stopping distance is the sum of the thinking distance and the braking distance. So let's consider thinking distance. How far will you travel given your reaction speed? Given how quickly you can react from seeing an object to responding to it by placing your foot on the brake. So we'll consider two scenarios. First of all, on the left, a driver with a reaction time of 0.3 seconds is driving a car at 30 meters per second. That's approximately 60 miles an hour. Calculate the thinking distance of the driver at that speed. So the thinking distance is how far the driver will travel between noticing the object jump out in front of them and being able to respond to it by placing their foot on the brake. So, step 1. We write down the variables we have been given. We have that velocity is 30, time is 0.3, and the displacement is what we're looking for. Step 2, write down the relevant equation. Well, the equation that I know is relating v, t, and s is the velocity is equal to displacement over time. Step 3, we substitute in the numbers. Step 4, we transpose, in other words, rearrange the equation. And we find that for a person with a very quick thinking distance, they are able to stop their vehicle in 9 meters. Meanwhile, a driver with a reaction time of 0.9 seconds is driving a car at 20 meters per second. Calculate the thinking distance of the driver at that speed. We write down our variables again, write down the equation, substitute in the numbers, and transpose. That is, rearrange the equation. And in this case, we find that the stopping distance will be much greater because the thinking distance is now 18 meters. This is all based on how long it takes a driver to react to seeing an obstacle. This can be affected by both age and whether or not the person has consumed alcohol. Alcohol slows your reaction speed. That means it takes longer for you to react. So the person on the right could be under the influence of alcohol, which increases their thinking distance, which then increases their stopping distance. Next, we have the braking distance. This is how far the vehicle travels once the brakes have been applied. Now this is down to the force of the road on the tyres and the force of the tyres on the road. This is a force couple, and this will be based on the friction between the tyre and the road. So in wet conditions, the friction will be lower, and so therefore the vehicle will travel further. So if we consider the equation that the acceleration equals the force divided by the mass, we can see several factors that might affect the ability to decelerate. If the force is smaller, in other words, the friction is lower because there is oil or water on the road, then the acceleration will be lower, so the car will travel further when it is braking. Also, if the car is loaded with luggage and passengers, because the mass is greater, that means the acceleration, or the deceleration in this case, will also be less. So a car that is overloaded with luggage and has extra passengers will have a longer stopping distance, because the braking distance will be longer.